Thank you very much. Those are some amazing images. Our next presenter is Sian Hong. So, come on up. Welcome.
Hello, I'm Sian Hong. This was my second summer in Dr. Liu's lab, and this summer it was kind of a continuation of what I did last summer about neurogenesis, so I'll tell you all about it. So some background, essentially neurogenesis is when neurons are born out of neural stem cells, and in adult mammals this particularly occurs in the subventricular zone and the dendritic of the hippocampus, and abbreviated as DG, and we'll be looking at DG today. So it's widely understood that neurogenesis slows down with age, and our lab is also concerned with the relationship between type 2 diabetes and neurogenesis. So last year we looked, here's some data from last year, just to set some groundwork. As you can see, so the red is the diabetic mice, the DB mice, and the green is our non-diabetic mice, our DB plus mice. And you can see, here's the age. So as the mice got older, we saw less neurogenesis, or like less expression of the markers. And so, less expression in the diabetic mice, also in the older mice. So what we're trying to find out this year, this summer, is why do the diabetic mice have less neurogenesis? Is it because they are just predisposed to have this decrease, or is it because of the environment that the type 2 diabetes creates with them? Because we know type 2 diabetes is an inflammatory disease. So what we did is cell culture. So by doing cell culture, we took neural stem cells from DB plus mice and our diabetic DB mice. And when you culture neural stem cells, they grow into neurospheres, and we counted the neurospheres and kept track of their size to compare our DB plus mice and our DB mice. So by using cell culture and putting these spheres and cells into like healthy medium, we can eliminate our factor of environment and see how our DB plus mice spheres grow in comparison to our DB mice. And if we see a difference, if we see a decrease in our, if we see that our DB mice have less spheres or smaller spheres, then we can argue that there's a biological defect in our DB mice. So here's kind of our data. We have a very small sample size. It's about like 2 mice in each group, so our results are not that significant, at least not yet. But here you can already see in each group there's kind of an age effect, so there are less spheres as the mice got older. And you can also see the DB plus mice, our non-diabetic mice, they tended to have more spheres than our diabetic mice. And in conclusion, we will collect data from more mice to to see if our findings can be confirmed. We're trying to confirm if, yes, does age really have an effect, which we expect that it does, and but most importantly, we're trying to see if there's a biological defect in our DB mice. So for more information on this, you can check out my poster, and we also have data for our nerve stem cell differentiation, so how these stem cells differentiate and how it's affected by diabetes, age, and ischemic stroke. So we also looked a little bit at ischemic stroke because diabetes is a risk factor for ischemic stroke, so they're all related. And in the future, right now actually we're working on putting our neural stem cells in a high glucose condition rather than like a normal healthy medium condition, and see how that affects our DB mice, DB plus mice, DB and DB plus mice. And also we're going to look more at ischemic stroke and how maybe we can use that in cell culture as well. So thank you very, very much to our LSRP directors, Kilpatrick and John, and the rest of our LSRP family, and thank you to Dr. Liu for taking me in for 2 summers, and thank you to the rest of our lab for supporting me, and thanks to my mentor for tolerating me. Thank you. Any questions? No? Okay. Thank you.
Thank you, Sian. And our next presenter is going to be Dylan Hope. So come on up.